All right, here are solutions for perfect problem 6 for Math 65. Doing a bunch of factoring. First, we're asked to factor x squared plus 2x minus 8. So when you're trying to factor x squared plus 2x minus 8, what you need to do is find two numbers that add to 2. Because 2 is the coefficient on the x term here, and multiply to negative 8, because negative 8 is the constant term here. So I think the easiest way to do that is list out everything that multiplies to 8. So maybe I'll do that off to the side here. 8, well, let's see, that's 1 times 8, or it's 2 times 4. These are all the different integer pairs that multiply to 8. And I guess negative 1 and negative 8 would work, and negative 2 and negative 4 would work. So I have all the numbers, all the positive numbers I can multiply together to get 8. And then if I want it to multiply to negative 8, one of these two has to be negative. So what you do is look at these pairs. This pair, can I make one of these two numbers negative and add them together and get 2? And I don't think you can. But with this pair here, if we make one of the two numbers negative, specifically if we make this negative, we can add these together and they'll add to 2 and multiply to negative 8. So find those two numbers. Those two numbers are negative 2 and positive 4. And then so what you can do is you can write this as x minus 2 and x plus 4. And if you're not sure if you did that right, you can multiply these guys back together. You can check your answer. FOIL, or we've been doing this box method in class, where if you want to multiply polynomials, kind of make this little grid and fill in all the boxes. So x times x is x squared, x times negative 2 is negative 2x, x times positive 4 is positive 4x, and negative 2 times 4 is negative 8. And now if you add up these terms, we get x squared plus 4x minus 2x minus 8. Combine like terms and you get x squared plus 2x minus 8, which sure enough is what we wanted to get. Good, that means we did everything right. Move on to the second problem. Second problem, a little bit harder. We want to factor 6x squared plus 17x minus 3. This problem is more difficult because the leading coefficient is not a 1. When the leading coefficient is a 1, you can just use the method we used above, but when it's not, what you got to do is kind of add a few more steps. You first find two numbers that, and kind of similar to what we did before, except now we want them to add to whatever a times c is, whatever the coefficient on the x squared term is. Sorry, that's not true. You want to add to the middle term. You want to add to 17, but you want it to multiply to the coefficient on the x squared term times the constant term out here. So 6 times negative 3, we want these to multiply to negative 18. So we got to find two numbers that add to 17 and multiply. I guess that says multiply. Let me do that again. Multiply. Just looks weird. To negative 18. And I think the easiest way to do that is, again, start with what we want to multiply to. 18, we can get it as 1 times 18. We can get there as 2 times 9. We can get there as 3 times 6. We can get there, I think that's it. Yeah, all the different integer pairs that will multiply to 18 are here. So we've got these three possibilities. We want to multiply to negative 18, so one number has to be negative in each of these pairs. So can we make one of these numbers negative and have them add up to be positive 17? Looks like that'll work with this first pair if we choose positive 18 and negative 1. So this is just step 1, so maybe I'll say step 1 is to find two numbers that do this. Step 2 is to replace your middle term. So replace 17x with this many x and this many x. In other words, with negative 1x plus 18x. Take those two numbers you just found here and make those the coefficients on your x term. In other words, rewrite this polynomial, 6x squared, but instead of writing 17x in the middle, write minus 1x plus 18x minus 3. I don't know why I changed back to blue. Maybe I'll stick with blue. Sure. So step 2 gets you to here. We're still not done. All we've done is changed our polynomial with 3 terms into a polynomial with 4 terms. But that's actually good news, because when you have a polynomial with 4 terms, you can start step 3, which is factor by grouping. So to factor by grouping, you look at the first 2 terms, 6x squared minus x, and look for their greatest common factor. In this case, it's x. So if we pull out an x from 6x squared, we'd be left with 6x. If we pull out an x from negative x, we're left with negative 1. And then you take your next 2 terms here, and what you got to figure out is what can you pull out from these 2 terms so that when you pull that out, you're left with 6x minus 1. And the answer to that question is pull out a positive 3. Pull out 3 from 18x and you'll be left with 6x. Pull out 3 from negative 3 and you'll be left with negative 1. And now what I have here are 2 terms, and each of these terms have a 6x minus 1 in them. So you can pull out that 6x minus 1 from both terms. 1 term, 2 terms, they both have a 6x minus 1 in them. So I factor out that 6x minus 1, and then what I'm left with is x plus 3. So I get my final answer is this thing, which it asked me to check. Sure, I can do that. 6x minus 1, x plus 3. We use this box method. It's equivalent to using FOIL to figure out the product of these polynomials. Although maybe it's a little better than FOIL, because FOIL only works when you have 2 times 2, a binomial times a binomial. Anyways, multiplying. X times 6x is 6x squared. X times negative 1 is negative 1x. 3 times 6x is 18x. And 3 times negative 1 is negative 3. So what we get is when we multiply those together, you get 6x squared plus 18x minus 1x minus 3, which is the same as 6x squared plus, it's hard to read, 6x squared plus 17x minus 3. And sure enough, that's what we're supposed to get. Our answer checks. We did everything right. We are done factoring, done with this problem.